Awesome. All right, you're being recorded. Katie, you want to go ahead and kick us off?
Yeah, absolutely. That was a great intro. Perfect scene setting. My name is Katie. Nice to meet everyone. Today I'm going to talk about open science, a little bit of how this relates to data communication, how both of them can be used to basically make data science accessible to more people. So overview, what I'll talk about, we'll do introductions. I'll talk about data communication and open science and how they advance similar goals. I'll talk about a machine learning competition that we did at DrivenData that was designed to advance open science. And then we will take open science to space. And I will talk about kind of a case study of how using open science in data visualization plays out using satellite imagery. And please interrupt with questions at any point. Feel free to unmute, feel free to post in the chat. We have plenty of time for discussion, so I'm excited to hear from all of you. Start with some intros. As I mentioned, my name is Katie. I am a senior data scientist at DrivenData. I've been here for about 3 years. I, like many people, had a bit of a circuitous route to data science. So my background is in chemistry, and then I worked in education and then went back to school for a master's in international development, where I focused on data science for good. So I think, like many people, have somewhat of an interdisciplinary experience and approach to data science. But it's a fairly small group, so I would love to hear a little bit about the folks here. If you want to just post in the chat your name and either your current role or just something you're interested in the data sphere, maybe what subject area or sector you work in. We'd love to just get a sense of who is joining us. But while folks do that, I will go ahead and give a quick introduction to DrivenData, which Katie already covered the main points here, which is perfect. Like Katie said, we work at the intersection of data science and social impact. So we help a lot of different organizations use machine learning effectively in their work. We work with folks anywhere from public health to conservation, financial inclusion, across a lot of subject areas. And we have 2 main ways that we work. We do your typical direct consulting, and then we also host open source machine learning competitions. So we'll be talking about one of these today. The way that these work is that we have our own platform where we can host custom competitions, and they're public facing. Anyone can come in and compete for prizes in one of the competitions. Usually there is a monetary prize. And most of these are some type of modeling challenge. So in most cases, folks are building a model, they submit predictions on some test set, and they are scored based on their performance on that test set. However, we do have some more kind of open-ended qualitative challenges, and I will be talking about one of those today. So what we're going to get into some details on is our Pale Blue Dot Visualization Challenge. This is a challenge we hosted recently that asked participants to create a visualization using Earth observation data that furthered the Sustainable Development Goals, or a couple of Sustainable Development Goals in particular. The prize for this program is that the top folks get to go to a 10-day space exchange program with travel and lodging and tuition covered. So they'll go to space camp in Alabama and then come to Washington, D.C., which is also where I live, and have meetings with policymakers and innovators about the future of space. And a large focus of this competition was on open science, both in terms of how we ran the competition and what we asked of participants. So I will get started talking a bit about what open science is and why it matters. But first, let's see a little of who we have joining us. We've got some nonprofit folks, some medical folks. Great. So we've got a couple of folks with different backgrounds, which is perfect. And feel free to jump in at any point with questions or comments, and we'll make sure to revisit them in discussion. So what is open science? How does it relate to data communication? Why does it all matter? So as a fan of data communication myself, I know that why I care about data communication is that data communication is about translating complex quantitative trends or ideas into compelling narratives that make sense to more people and that matter to more people. So big picture, I think this, at least in our work, the goal of good data communication is kind of about expanding our data science umbrella. So we are working to enable a more diverse and inclusive set of perspectives to understand and participate in discussions around data science, in particular, enabling less technical folks, folks from underrepresented groups, folks who face more barriers. Data communication is about enabling more people to participate in the dialogue around data science. So if you are a fan of data communication and these goals, you will also probably like open science. So open science is basically another tool that can help us accomplish a lot of these same things and can help us bring more people into this data science tent. So open science is defined as the principle and practice of making research products and processes available to all while respecting diverse cultures, maintaining security and privacy, and fostering collaborations, reproducibility, and equity. What this means is that open science provides us with a set of best practice recommendations for how to make the work that we do more inclusive and accessible to folks, and also how to change the way that we practice science, the way that we practice data science, to make the field as a whole more inclusive and equitable, and to also change who is participating in scientific research. So this is what open science is. That's a pretty broad description, a pretty broad mandate, and it can mean a lot of different things. So I'll take a minute to talk about what this can actually look like in the context of data visualization. So thinking about what are some of the specific open science principles that in particular apply to data visualization projects. And this is just the tip of the iceberg of a lot of literature out there on open science, but we have to start somewhere. So the first is be transparent, document the process of creating your visual. The idea is that you are enabling others to completely reproduce what you have done from your original data. And this will be a common theme throughout a lot of these tips. Second is to use publicly available tools and data. So not just to enable folks to reproduce your work, but to enable them to reproduce it for free. Another is working in context. So thinking about the equity component of open science, in our work, taking time to learn about historical, social, political context that we are operating in, understanding how our work affects that context. And this also, another way to do this is really engaging with community members who are impacted by the issues we're working on. So really trying to bring in a more diverse set of voices into the work that we're actually doing and giving impacted community members, kind of bringing them in as co-creators. Similarly, identifying and mitigating biases. So thinking about the various ways that bias is introduced in the data we're using. Something we like to say is the question isn't, is my data biased? The question is, how is my data biased? All data is collected by humans in a specific context. All data is biased. And so this is about thinking about what are those biases? How can we maybe mitigate those? And I'll do a quick plug for a tool that was actually created by DrivenData. So this is, Dion is something that we created to help folks approach these conversations during a data science project. So it's an ethics checklist that's easily integratable into any data science project. So at each stage of a data science project, all the way from data collection to deployment, it walks through some of the most important ethical questions to talk about. Even if you can't come up with solutions for all of them, just ways to make sure we're articulating trade-offs that we're making and mitigating anything that we can mitigate. Write reproducible code. So generally, just use good coding practices, write code that others can easily follow or contribute to, and in particular, encouraging folks to share their code on GitHub, which is a great platform for collaboration and for building open source code. I'll plug another driven data tool here called Cookie Cutter Data Science, which is basically a standardized project structure for code that helps you figure out things like where to put types of code that do different tasks, how to manage different environments, basically just setting up your code base in a way that will be easier for others to follow and easier for you to continue building on. But that is the last driven data tool that I will plug. And then finally, collaborate. So this relates to some of the other tips here as well, but the idea of just engaging with others, especially across disciplines and demographics, recognizing that issues are interdisciplinary, and we as data scientists don't have all the answers, making sure we're drawing on other perspectives as well. And one useful tool that folks should know about is called Open Science 101. It's a free training program from NASA as part of their Transform to Open Science initiative. And NASA was a partner on the competition we'll talk about later. But this is an either in-person or online training program that introduces folks to the principles and practices of open science, because there is a lot more than just what I have talked about here. Any questions about the introduction to open science, kind of what it is, how it relates to data communication, and why it matters? Feel free to unmute or post in the chat. All right, great. Well, I'll keep an eye on the chat. If anyone is still typing or putting their thoughts together, feel free to still put in those questions. So now that we have a sense of what open science is, I'll talk through how this played out specifically in the setting of a machine learning competition. So I'll talk about a competition we designed that was part of NASA's Transform to Open Science initiative, and how open science played out. So we had a couple of partners on this project. We were working with NASA, as I mentioned, as well as the UN mission to international organizations in Vienna and the UN Office for Outer Space Affairs. And we wanted to design a competition that did two main things. There were two main goals we wanted to accomplish. The first was promoting open science. So sort of as part of NASA's Transform to Open Science initiative, helping get those practices out there, bring more people into the world of open science and introduce them to open science principles. And the second was to increase engagement with publicly available Earth observation data. And Earth observation data just means any data about life on Earth that is collected from space. So the main type of data here is satellite imagery, but that is not the only type of Earth observation data. And this was of interest because the US government collects a ton of satellite data that's all publicly available, and the partners really wanted to make sure that it was being used to its fullest potential, especially in areas of really high impact. So in this case, that was articulated as being the Sustainable Development Goals. And satellite data, I think, is a good case of open science being particularly important because it can be pretty complicated. It can be really hard to work with. There's kind of a high barrier to entry. So it's especially important to make it easier for folks to enter that conversation. So this is where we started with in designing this competition. So this is fairly open-ended. And one of the things that we had to decide is, what do we actually want participants to submit as part of this competition? What do we want to be judging? And we decided that it made sense to frame this as a data visualization challenge. So bringing us back to the data visualization, data communication world. This was a good fit here because it provided some structure for beginners while also allowing flexibility for experts. It also gives a fairly low barrier to entry someone can create an interesting visual in a lot of different ways. They don't necessarily have to use a coding language. A lot of people used Python. Many people did not. There were no technical coding requirements for this competition. And then thirdly, satellite imagery is cool. There's a ton of very exciting satellite imagery that is publicly available. There's just a lot of really good fodder to create nice visualizations. So just one example of this, I know a lot of folks are out west, so you might have heard about the ephemeral lake that popped up in Death Valley after a hurricane in August 2023. We can actually see that from space in the satellite imagery. We can see what Death Valley looked like before. We can see this ephemeral lake after it formed in August of 2023. And then we can even see after the atmospheric rivers that came through California in February 2024, we can also see that that lake has persisted and continued to exist even in this extremely dry place. So generally, this was a good vehicle for open science principles. And a couple other things we did to foster open science, just to give more sense of, what open science can look like and actually trying to embrace it can look like. We provided a lot of participant resources to help folks get started. So we had a competition forum where folks could ask questions. We had a very long blog post with an overview of various Earth observation data resources, which is was a good resource both for the competition and more generally provides a really good overview of some of the satellite data sources that exist and some of the main tools that exist and how to get started. We also worked with NASA to put on a couple of live tutorials with experts about how to use a couple of key tools and data sets. And we designed evaluation criteria that put emphasis on a lot of the qualitative skills that we wanted to see. So that put more emphasis on the equity part of open science, on how well folks engaged with the context of their work, how well folks thought about risks of bias, with the idea that we both did want to value those things and recognize submissions that did those things well, even if they weren't as technically advanced. And we just wanted to kind of build confidence for folks who might be newer to the technical side of this, but feel that they have real understanding of the issues or personal experience with the issues. We wanted to kind of let folks know that that was really valued in the competition. We also did some targeted outreach, specifically to universities, because the prize for this challenge is attending the space study program. We thought students were a very good group. We did a lot of targeted outreach to various university and school affiliated groups. And then finally, in addition to our main prize, we added a bunch of honorable mentions to give out to a larger group of the most compelling visuals, so that folks, even if they didn't feel confident that they would be among the top submissions, were still incentivized to participate and saw that they could still be recognized. Any questions about the competition in general or how our competitions work at DrivenData? And again, feel free to, not to speak now or forever hold your peace, feel free to put anything in the chat if you think of anything later.
I'm not seeing anything.
Great. All right. So this is how we designed the challenge. Again, our goal was to both encourage participants to use open science and to embody open science in the way that we ran the competition. The competition closed at the end of January. So right now we're still finishing up choosing the winners and verifying all those winners, but the results will all be posted on our website in the next couple of weeks. So definitely keep an eye on that. But we saw great participation. We had almost 1,600 folks who registered. We had great geographic diversity, so over 100 countries. We also saw that all these resources we provided, it did make a difference. And 70% of participants had never worked with Earth observation data before. So we were able to kind of enable people to start their satellite data journey. And we also saw this in reviewing the submissions, that there was just a huge range in what technical tools folks used, which was great because for this competition, kind of the main purpose wasn't necessarily the submissions themselves. The main purpose was the process of getting folks to engage with this data, getting folks to understand the potential and how Earth observation data could be used to solve pressing challenges today. So now that we know a bit about the competition and the nitty-gritty details of it, I will zoom back out, very far out to space, and talk about some of the things we learned through that process. So specifically, ways that we saw folks being able to use open science when visualizing satellite imagery. So we'll kind of take this as a case study of, great, I want to use open science, I'm on board, but I'm not sure how to do that. What specifically does that look like when I'm creating a data visualization? We'll walk through some tips in the context of satellite imagery. So the first is that there are a lot of beginner-friendly online interfaces to explore Earth observation data. So folks getting started with satellite imagery, things like NASA Worldview could help them see various sources of satellite data, bring in multiple different satellites or missions as layers, all without using any code at all. So again, this is a free tool that's very beginner friendly, kind of helping get people on board and helping people find relevant pieces of satellite data. And again, here, a good resource is the blog post we wrote as part of this competition, which outlines not just NASA Worldview, but a variety of other tools that exist publicly online that help folks get started with satellite data because it can be a particularly complicated data source that's really hard to figure out how to use. The second is that there is a ton of publicly available Earth observation data, especially satellite data. So going into the competition, we knew that there's a lot of US government publicly available data. That's part of why our partners wanted to do the competition. We saw that folks use a huge variety of different types of data sets and bring in data sets from outside of the US government, from other governments, other publicly available sources, and just demonstrating how much is out there, and that doing this in the spirit of open science, using publicly available data sets and tools really wasn't constraining for folks. They were able to find a data set for almost any topic they wanted to work on. So just one example here is Landsat satellite imagery. So this is actually, I believe, the longest continuous space-based record of Earth's land in existence. So it's been around for a long time. It is a really popular source of visual Earth imagery. But in addition to that, it includes different wavelengths that detects things like clouds or temperature or infrared light. So one of the top submissions we saw used Landsat data to map solar panel suitability across the Turks and Caicos Islands. And specifically what it took in from Landsat was one, surface temperature data. So solar panels work best at 25 degrees Celsius or below. And then second, it was able to bring in vegetation data from Landsat, taking into account the fact that solar panels work best in areas that are not obstructed by vegetation. So Landsat is one source that people talk about a lot, but just to give a sense of how much is out there, this is just US government data sources and just a snapshot of some of the ones that we highlighted for this competition. But this is, again, the tip of the iceberg. You can see multiple satellite imagery sources. So in addition to Landsat, things like MODIS, and then some of those different types of Earth observation data that aren't satellite imagery. So for example, JEDI is a data source where, based on like lasers, which I don't understand how this works at all, but it is a laser constructed 3D map of forests. So there's a lot of different things that this data can look like. There's a data set out there for almost any kind of Earth science application that folks might be interested in. In addition to freely available data, there are wonderful open source tools that exist out there. This, I think, is not just related to data visualization, but something that holds across a lot of programming. And we saw that really borne out among the competition submissions. Things like Python are great open source tools. There's a lot of excellent open source libraries that exist. And again, we really saw that sticking to publicly available tools was not much of a constraint, and folks were still able to accomplish pretty much anything they wanted to take on. So to give another example, this is another one of our top submissions, and this group tracked the concentration of microplastics along the Brazilian coast over time. And they created this entirely in Python using open source libraries. So just to name a few popular ones, they used Xarray to process data. NumPy is a very popular statistics package. Matplotlib, an extremely widely used plotting package. And then CartoPy for creating geospatial plots specifically. And this just scratches the surface. And not all of our submissions use Python, but it's just another example of there being really good open source resources that allow folks to make their work extremely accessible to others. And in addition to some of those coding tools, there's also really good tools for sharing code. So GitHub, like I mentioned before, most of our top submissions made their code available on GitHub. So we saw them really embrace this idea of collaboration, of making their whole process available through things like GitHub. And then finally, we saw a lot of submissions that did a really good job of incorporating local perspectives to engage with issues more productively. So again, in that vein of thinking about the collaboration and equity piece of open science and about kind of changing who has agency in the data science work we do and the conversations we have around that work. A couple examples that we saw. One is pictured here. This is another one of our top submissions where the group visualized groundwater level in the Gambia to think about where would be the best locations to drill wells to provide access to clean water for folks. And this team actually connected through the competition and collaborated with one another across continents. So there were 2 folks from Argentina, 1 person from the US, and 1 person from Senegal on this team. And they, as part of their work, they actually connected with some existing NGOs in the Gambia and spoke to community leaders on the ground who were already involved in this kind of work to help inform their perspective of how clean water scarcity affected people's lives and what would be the most helpful tools to make available. So that's on the kind of engaging with context on the research side. And then we also saw some examples of folks really drawing on firsthand experience. So another team was 2 folks who are work in the GIS field and are based in Nairobi. And they, in their submission, they studied food insecurity in northern Kenya. And they were able to draw from both of their experiences. They had actually worked in northeastern Kenya and had connections with community members experiencing these issues and were able to really incorporate that perspective in what they created. And I think the general trend we see here, they actually described very well in the report that they wrote as part of their submission. So they reported that the direct interaction with communities added a human element to their research, and the personal connection reinforced their commitment to developing practical solutions. So part of that, the idea in open science of bringing in more perspectives and having a more equitable representation, I think really enhances the quality of solutions because folks are able to build tools that speak to an actual need based on a more kind of nuanced understanding of conditions on the ground. So that is a quick overview of one specific case study for open science. And now we can move to discussion. First, I'll just wrap up. What did we actually learn today? What did we talk about? We learned about open science as another tool that advances similar goals to good data communication and can bring more people into that data science tent. We saw some different ways that open science can play out and that it encompasses a lot of different practices. So seeing how it played out in the design of a competition, as well as in specific data visualizations. And then we saw that in this competition, in the context of Earth observation data and creating visuals from satellite imagery, sticking to these open science principles really didn't limit competition submissions. There were plenty of data sets, plenty of tools, and in many cases, it actually enhanced them by encouraging folks to engage more deeply with the context of their work. Great. Well, I'll turn it over to Jasmine to facilitate the discussion. Thank you.
Yes, thank you so much, Katie. And I apologize. I picked a tea shop because I thought it would be quiet, and they're blasting K-pop. So,
well, we can't hear any of that in the background.
Oh,
at least I can, so I think you're good.
Good. So, does anybody have any questions for Katie? Please go ahead and raise your hand, or if you aren't able to, then just come off of mute. I have a question, so maybe I'll kick them off. I would like to, first of all, the winners of the competition getting sent to Alabama, is that Redstone Arsenal?
I'm not
down
sure.
in Huntsville?
Yes, it's through the University of Huntsville, Alabama. So
Okay, yeah, and they
right.
partner a lot with Redstone, and then also I think Raytheon is down there as well.
Oh.
So yeah, a lot of amazing. I used to work projects there, so like lots of cool stuff there. Great. For sure. But another question I had for you, what are some of in practice, what are some of the pitfalls that you've seen where open science isn't adequately employed during the course of a project?
Yeah, absolutely. I think because we work mostly in Python, we work on a lot of programming. I think we see a lot of projects where folks haven't followed best coding practices to enable others to build on their work. So things where it's hard to follow where code lives in a certain program or where code breaks easily. So I think it really goes hand in hand with a lot of the best practices for coding and for building open source packages. So I think that is one example. And I think another is the transparency and reproducibility. So particularly for complicated data pipelines where there's a lot of data cleaning, folks have to make a lot of decisions. How do we handle missing values or whatever other weird data quirk folks run into? Those things often just aren't totally documented, which can make it hard for people to build on others' work or to reproduce it. And then I think in general, data bias and mitigating data bias is not discussed nearly as much as it should be. We actually have another recent project looking at algorithmic bias in mental health research. And one of the things we found is that just the vast majority of research papers don't discuss this at all. And there are actually some fairly simple mitigation methods folks can use to make data more representative, or even just considering the representativeness of their data. I think that would be another big one, that there's a big gap out there in how much folks think about it, and how much in an ideal world folks would think about it.
Are there any partners that you work with in Colorado or the Denver area?
One of our team members is actually based in Denver, but no other specific Denver-based companies are coming to mind.
I just think of so many use cases for this kind of work, and I think I'm going to follow up with you. And I see we have a question
Love that.
Yay. Okay, Michael, go ahead and come off mute.
Yeah, I was wondering to the point of having code that people can reuse and understand kind of how they got to the conclusions they did. I've been seeing a few people using more literate programming techniques to generate code. I personally use Quarto for a lot of my research work, where the code is basically generates the document that I end up publishing. But have you seen anybody else using anything else? Those are I've used them primarily for small projects, but for larger data analysis projects, it would be substantially difficult to do so. So have you seen anybody using anything like that?
I'm not sure. Can you describe a little bit more what the tools actually do? I'm not as familiar with kind of the research side. I don't know that I've heard of these.
Sure. There's a few languages that have made it easier, but I think one of the most popular one is using like Jupyter notebooks, where you can put inline markdown, you can put figures and so on and so forth, and then you can end up generating a nice website out of it using tools like Quarto. Quarto is big in the R space, and I think it's becoming more and more useful outside of that.
Great. Yeah, that absolutely makes sense. I do think Jupyter Notebook is the main one that we see where the code that you're doing is directly embedded in the final narrative, where it's just great to pull in. I think, yeah, Jupyter Notebooks is the main one that we see working in Python. And I think you can also use a lot of different languages in Jupyter, so it's definitely not exclusive to Python.
Fantastic. Thanks.
Are there any other questions for Katie? We've still got about almost 15 minutes left, or a little over 15 minutes left. Katie.
I have a question, if that's okay. So, Katie, I'm curious. I think like in the data visualization space, there are a lot of tools that maybe aren't so great for analysis or do like light analysis. I'm thinking like Power BI or some of the Google tools or Tableau. Did you have any submissions kind of using those or doing kind of lighter analysis, or did most folks kind of use like Python and GIS and fancier, I don't want to say fancier, but maybe slightly more advanced tools?
Yeah, absolutely. We saw a lot of those. Definitely a lot of folks using Power BI, a lot of folks using like QGIS, and we even had folks who, I mentioned those beginner-friendly online tools where you could add in layers. We had things all the way from folks who just created something with that and then screenshotted it, all the way to folks who, fit a machine learning model and then visualized that. So we did see a big range, even some people who just imported data into Excel, created visualizations in Excel. We had some Tableau submissions as well. So, and I think this was part of why we really wanted to have those honorable mentions, because most of the top submissions that were chosen by our judges for the Space Exchange Program Prize, I think all but one used Python. But amongst the larger field and amongst those honorable mentions, we see a much wider variety of the tools folks use, and a lot more folks who didn't use as kind of a high barrier of a coding tool.
Awesome.
How?
Go ahead, Jessamine.
So I was wondering if there are what the criteria are for if folks wanted to get involved in one of these competitions in some way. I imagine there are different avenues for that, and I was just wondering, like, what are the criteria for being able to get involved in one of these competitions in some way?
Yeah, anyone can get involved in the competition. I'll just send a quick link to our page of competitions. They are completely public, so anyone can participate. There is a big range, so there are some practice competitions or just for fun, easier competitions, all the way to some of our prize competitions that are, much more complicated machine learning tasks. So there's really no requirement. All you got to do is go to the website, pick a competition, and you can participate.
Katie, I have one more question. That's so a lot of what you showed is really cool, and I imagine folks would be, government officials and things like that would be interested in leveraging some of that. Did you see kind of those folks reach out? I know you mentioned the one group connected with NGOs, or is there kind of more momentum to apply some of the findings from this, or is it kind of just, if you competed and that's really cool?
Yeah, so this competition is actually a little different than most of our others in that respect, where the main thing the partners cared about was getting more folks to engage with Earth observation data and understand all of the different things it can do. But most of our other competitions are geared more towards carrying a model forward. So just to give one example, we had a recent competition to detect harmful algal blooms from satellite imagery. So looking at satellite imagery and being able to tell, is this reservoir water safe to drink, that kind of thing. And that was in partnership with NASA and some other more local water management groups. So something like that is being taken forward and kind of can go directly into a workflow. This competition was less focused on that step of carrying it forward, but we did see, we saw some folks who are, entrepreneurs, run small businesses, talked about something that impacted the work that they did and has the potential to be carried forward, as well as folks who were hoping to take their solutions forward and keep working on it after the competition.
Any other last questions? I'll just have to give it 7 seconds. Well, Katie, thank you so much for this wonderful presentation. I particularly enjoyed the idea of open science. It's something that I preach all the time, but now I have it like an actual name and resources to attach to it. Inclusivity is such I think a paramount thing when it comes to anything from data analytics to data science and any kind of things that are going to be causing folks to make decisions. And if you ignore bias, or you're not taking things into account, if you're not being inclusive in the way that you build teams and do the analysis, then you end up in really precarious situations. And we've seen, TED talks about that and things in the news. And I think a lot of tech companies are now starting to build out entire teams to mitigate some of the issues that have been caused by not following, that principle that DrivenData seems to just adopt at heart from the start, and encourages. So thank you so much for sharing both a bit about open science, but as well as how it's been applied and how it was interesting to me to see that like the majority of the top candidates were using open source and free resources. And it's something that I preach all the time, like use Python, use R, use things that are inclusive, that somebody could repeat, document your code, make sure that people understand what you're doing, so if they want to build on your work that they can. I loved hearing you share a bit more about that. So thank you so much for your time. And I appreciate your patience with my K-pop in the background.
Can't even hear the K-pop. Turn it up. But yeah, thank you. Happy to talk about it. Definitely, if anyone has questions or other ideas, feel free to get in touch. We love hearing about ways that folks are using data and thinking about making data science, improving the data science ecosystem.
I will definitely be reaching out. I have so many ideas.
Great, can't wait.
Thank you, Katie. Katie B, thanks so much. And everybody for joining. I know some folks have already started dropping off, but hopefully everybody got something out of this. Those of you who asked questions, appreciate it. And everybody have a wonderful weekend. And if you're in the Colorado area,